There have been several types of whip checks made available over the years, some of which are still commonly in use. The earliest whip checks were a homemade type device, and when used in high pressure applications may fail, causing injury and damage. These sling type whip checks may look similar, but the whip check with the hemp string core wire rope failed at less than 1 tonne, while the whip check with the steel core wire rope had a braking strain of around 8 tonne. However, both failed to press the hose whip, as our tests will clearly show. These cable stocking whip checks, either in single or double leg, are designed to grip the hose ever more tightly in the event of a failure, and the merits of these will be demonstrated. As is the case right around Australia, the WA Mine Safety and Inspection Act 1994 places a duty of care on the manufacturers, suppliers and importers of whip checks to provide products which are fit for purpose. This duty requires the parties not only to manufacture or supply a product which is safe, but also to test that product. The first test used 2-inch hoses with sling-type whip checks which were attached to a tension load cell on the test rig. This was connected to an electronic force indicator, programmed and calibrated to a resolution of 5 kilograms. The compressor was started and the pressure raised to 350 psi. The air supply was then shut off as a solenoid valve was energized, releasing the hose. The procedure was then repeated at pressures of 400, 550 and 700 psi. The second part of the test program consisted of observing and recording how whip checks of different designs and configurations behaved in restraining a failed hose. The steel yoke was removed from the test rig and a short sling-type whip check was fitted to the 2-inch hose. Two shorter sling-type whip checks were also tried. This was followed by a single-leg cable stocking type whip check. And finally, a double leg of cable stocking. So the final recommendations are that all high-pressure hoses be fitted with cable stocking type whip checks. Construction should be of stainless steel or galvanised steel wire rope, and the completed unit must have a minimum of 900 millimetres hose grip. It must be fitted with 2 attaching legs, each no longer than 450 millimetres, with formed eyes. Full strength requirements are shown in the final report. All high-pressure clean air hoses should be fitted with internal whip checks as well as the external cable stockings. Where external whip checks are to be used on hoses with bolted fittings, such as the Dixon Boss style, the whip check should be manufactured to incorporate protection for the attaching legs. This may be provided by including a plastic or rubber hose over that part of the assembly. The whip check should be fastened to a mounting point provided for that purpose, and should be positioned where it is protected from damage and excess wear. Of course, the shackles or bolts must be of at least equal strength to that of the whip check itself, or the whole system is still likely to fail. Finally, employees must be made aware that the potential for a hose fitting failure is just as likely as for a failure of the hose itself. It is therefore essential that the hose and tail assemblies are matched.